Hi, this is second part of analysis of perfect frame, cantilever truss. A truss which is connected to wall or column at one end and free at the other end is known as a cantilever truss. In previous part, we discussed the simply supported trusses, so the support reactions are essential for start the work. Here there is no need of calculated support reactions. You can start the calculation from the free end of the cantilever. For example, a frame is shown here. You can start the calculation from the support, at the point A, joint A. Draw the free body line of joint A. Here, the vertical forces 10 kilonewtons acting downward, and the vertical component of AB is FAB sin 60. This equating this, we get FAB is equal to 11.5 kilonewton. Then resolve horizontally. The horizontal forces are horizontal force on the member AD and the horizontal component of AB, FAB cos 60. So equating these two, we get FAD is equal to 5.7675 kilonewton compression. Then consider the joint B, draw the free body diagram of the joint B and resolve vertically the vertical component of these two members. Vertical component of BD, FBD sin 60 and vertical component of AB is FAB sin 60. These are acting opposite, so equating these two, sin 60 cancel, then FBD is equal to FAB is 11.5 kilonewton. Then resolve horizontally, the horizontal force in BC is there and horizontal component of FBD cos 60 and horizontal component of AB is FAB cos 60. So FBC is equal to FBD cos 60 plus FAB cos 60, that is equal to, substitute the value of FBD and FAB, we get the value 11.5 kilonewton tension. Then another example, here we need to find out the angle CDE, theta. The tan theta is equal to 1 point the opposite side by adjacent side, that's 1.5 by 4.5. So tan inverse of 1.5 by 4.5 is 18.43 degree. The sin theta, sin 18.43 is 0.316 and cos theta is cos 18.43 is 0.949. Then consider the joint D. Draw the free body line of the joint D. Here the vertical forces 500 Newton is at the joint D and vertical component of force in CD. So FCD sin 18.43. Equating these two, we get FCD is equal to 1584 Newton tension. Then resolve horizontally. The horizontal member is there, force in D is there, and another horizontal force is horizontal component of CD. This FCD cos 18.43. So equating these two, we get the FD is equal to 1503 Newton compression. Then consider the joint E. At the joint, there are three forces, two of which are along a straight line. The third force is 0. Here, F, EF and FED are in a straight line. So FC is equal to 0. So FC is 0. Then resolve horizontally. Here, two horizontal forces equal and opposite. FDE that is equal to FEF that is equal to 1503 Newton. Then consider the joint C. Draw the free body ring of the joint C and resolve horizontally. The horizontal force of these three inclined members FBC cos 18.4 and horizontal component of this FCF cos 18.4, horizontal component of FCD cos 18.4. Then equating this FCB cos 18.4, FCF cos 18.4, FCD cos 18.4. Cos 18.4 is on both sides, cancel. then FCB is equal to FCF plus 1584. Solving vertically, vertical 1000 kilonewton is there, and the vertical component of these three members. FCD sine 18.4, then F, that is acting downward, then FCB BC sine 18.4 is acting upward, and FCF sine 18.4 is acting upward. Two forces are acting upward and two forces are acting downward. So downward force is equal to upward force. Then substitute the value of FC here. Then substitute here and open the bracket. Then we get another equation. And here these two right and left side is common, so it is cancelled. Then 1000 is equal to 2FCF sine 18.4. Therefore, sine FCF is equal to 1584 Newton compression. Then substituting the value CF in equation 1, we get the FBC. FBC is equal to 3186 Newton. Then consider the joint F. Joint F to solve horizontally. The horizontal forces of member FG, FE, and the horizontal component of CF. Horizontal component of CF is FCF cos 18.4. Two forces are towards the left. These two forces are towards left, and this is on towards right. So the rightward force is equal to leftward force. FG is equal to FCF cos 18.4 plus FA. Then FG is equal to, substitute the value of CF and then FE. Here we get 3087 Newton compression. Then to solve vertically, vertical force BF is there, member BF is there, vertical force of member BF, and vertical component of CF. Vertical component of CF is FCF sine 18.4. It is acting downward and the other force is acting upward. So equating these two, we get FBF is equal to 500 Newton tension. Then consider the joint B. Here we need the slope of the angle of PG is required. So the angle GBF is equal to, we take as theta, angle theta, and then tan theta is equal to opposite side 1.5 by the height is 1 meter. This is tan inverse of 1.5 by 1, that is 57.3 degree. Then horizontally resolve the forces at joint B. Horizontal component of FAB cos 18.4. Then horizontal component of FBG 18 sine 56.3. This sine 56.3 is makes with the vertical. So here sine 56.3. And horizontal component of BC FBC cos 18.4. This rightward force is equal to leftward force. Equating rightward force is equal to leftward force, we get another equation 0.876 FBG plus 3186. Here we the 0.9488 is divided on both sides. We get this equation. Then resolve vertically. Here the vertical force is 1000 Newton is there, and 500 Newton force in member BF is there. These two are acting downward, and the force in AB is vertical component of force in AB is FAB sine 18.4, and force in member BG is FBG cos 86.56 upward, and FBC is sine 18.4. The upward force is equal to downward force. There are three downward force 1500 and FBC sin 18.4 is downward and other these two forces are upward. Substituting the value of AB here and solving, we get FBG is equal to 1801 Newton compression. And substitute the value of FBG in equation 2, we get FAB is equal to 4757 Newton. Then method of section. In this method, the particular convenient to determine the force in a few members of the files are required. In this method, the section's line is passing through the member or members in which the forces are required to be found. For example, this triangle truss. If we need force in member and AB and member BC is required, then take a section through one. If we require another force in member AC is required, then take a section through section 2. So if the sections are selected in such a way that how many forces are required to find out. And the part of the structure, the section like the part of the structure on the right side or left side of the section is in equilibrium. So here the section 1 is taken. If we take a section 1, then the right of the section is equilibrium or left of the section is equilibrium. You can use left of the section or right of the section. Then they take the moment of the forces. Unknown forces are found out by applying moment of forces. The sigma m is equal to 0. If we this for the section 1, this part is in equilibrium. The right side part is equilibrium. You can take the moment about A or moment about C. Find out the other these force in member AB and force in member BC. Or we can take the equilibrium of the left part of this section and take the moment about A. Find out the member force in member BC. Or if you can take the moment about C, you can find out the force in member AB. And to start with the section 1 cutting the member AB and BC, and if we just find the section in the force in member AC, the section is taken 2 is this section is taken. While drawing the sections, the care should be taken not to cut more than 3 members, because the only one equation is here, so the cannot member is not more than 3. Some exercise. Thank you.